Hello, my name is Brandon. I'm an engineer and I'm going to design a diesel engine from start to finish. I own an engineering company and it's very seldom that I get to just do something for me. I spent so many years designing things for other people and companies. And I chose the diesel engine because I think that it's understated how important the diesel engine was to uh, the modern way of life. The guy who invented it was this guy, Rudolf Diesel, who died under mysterious circumstances. I mean, depending on how you look at it, he died on a ship passage across the Atlantic, I believe, and there was rumors that he was killed. Basically, he made this engine. Lots of people don't like diesel engines, but they are the most efficient combustion engine to this day, and we just couldn't live without them. And I'm going to design this engine at about somewhere between 2 and 3 liters. I'm not quite sure how many cylinders I'm going to do or anything like that. We're just going to play this by ear, and I'll show you how I design things from start to finish. Overseas, the diesel engine is a lot more prevalent than in the United States because there's less stringent emission standards overseas. And, maybe that's important to the United States. There's some pretty long form videos explaining how maybe the diesel engine isn't quite so bad if you look at it over the long term, especially when you think of how long they last. And so, I'm basically going to design an engine I wish that existed in the United States that I could buy in a car or truck and just see where it goes. So to start with, we need a cylinder, and I'll show you my design process. Basically, I start by making all the major components that I know exist first. And I don't make any effort to try to size them appropriately or fit them appropriately. I just do the best I can and just throw a bunch of stuff into the assembly. And then once I'm there, I kind of go back and start doing the math. And a lot of people won't care about math, and that's fine. The book that I'm going to be using as a reference is this textbook. And it's a really good book if you're into that kind of thing. And where appropriate, I'll basically decipher the math for you about what's happening and why. And it goes into so much detail. There's no way I could cover it all, nor would anyone want me to. But when I make decisions based on this book, I'll explain why. So the first thing you need in any engine is a cylinder. So let's just make a cylinder. So how did I do that? I just drew a circle and a box. I didn't really care how big this was. I'm estimating this 80 millimeter diameter for the bore based on this math right here. So basically, let's just say for now that the displacement that I want total in the engine is 2.5 liters. And let's just take a stab at 6 cylinders, which is a really good number of cylinders for a diesel engine because it's balanced inherently, which I'll explain when we get into balancing later. So if you basically take that 2.5 liters and divide it by 6, you get 25 cubic inches per cylinder. And I explain here how, okay, well, if we assume that the stroke of each piston is the same as its bore diameter, then I show how I can do a little bit of math here and guesstimate that the piston diameter and the cylinder bore diameter need to be about 80 or 81 millimeters. And so for that reason, I went ahead and put in 80 here. We can change it to whatever we want later. And then I extruded it downward a little bit longer than 80. I think I extruded it down 100 millimeters. So we have one cylinder, and anything I do to one cylinder, I can propagate and I can pattern to as many cylinders as I want, 2, 3, 4, 6, whatever. So we're just going to do everything on one cylinder until I'm satisfied, and then I'm going to pattern it to the number of cylinders that I want. Now, I will warn you, in the beginning, this process looks a little hokey because you just see a block and a cylinder, and there's a lot more complexity. But when you start, you just basically throw things at the design and then start whittling away and refining it until it looks more like you'd expect. All right, so you know that below the cylinder is going to have to be some space for a main crankshaft and a bunch of other stuff. So I extruded down a little bit of material. And then we know we're going to need a crankshaft, so the piston is going to act on, the piston is connected to the rod, and the rod is going to act on the crankshaft. So I put a hole in there to represent that for now. In real life, this is going to have a bearing or something in it. We'll worry about that later. So we need a piston to put inside of it, so let's make a piston. And for the piston, I have no idea how many rings I'm going to want in the piston, so I just put 3 in for now. That's a size, that's a number that's fairly common. And I know that if you have a direct injection diesel engine, meaning that the fuel is squirted in right here, then you're going to make this some sort of contour that facilitates the swirling of that fuel. If you do an indirect injection, you don't need this, but I went ahead and put just something in there as a placeholder. And then I revolved that into what you see here. And, you know, this piston has to connect to a rod somehow, so you need a hole in it. So I went ahead and put a hole in it. I'm not sure how big that hole is going to be or what kind of snap ring grooves I'm going to need later, but for now it's just a piston with a hole. So if I put those two things together, now I have a piston, one piston and one cylinder block. And that's the starting point. So the next thing that we'll put in there is the rod. So let's make a rod. So I'm not sure how long this rod will be yet, but we do know that it'll at least have a couple of holes, one top, one bottom. And we know that it's going to do something to connect those two. So let's just fake in these for now. And something like this, something like this. And I know from experience that this is going to be split at the bottom, but we'll worry about that later. We'll extrude that out. No idea how thick yet, but we'll just put that in there for now. Save that as piston rod. We'll throw some dimensions on it so we can change them later. And in terms of how long it is, no idea. I don't know. I'll make it something like that for now. Make this a little fatter. Too fat. All right. We go back to the assembly and throw that in there. And you can see just visually looking at it, you know it's going to be too small, but that's fine. You know that it's going to connect somewhere around there. And just visually, you can start massaging this to start getting it closer to what you know will probably be reality. Let's make it on the same plane as this surface. Here we go. All right, so obviously way too small, right? This thing is rotating around in here. So let's go a little bigger. And let's make it, I don't know, let's make it the same. Let's make it 100. Let's make this 20. Make this 30. Oops. Make this about 35. 12. 14. Long way to go, but hey. All right. And hopefully this piston doesn't have to be quite so long, but we'll see. And maybe this 60 only has to be 50. I'm not sure. Okay. All right, so what else do we need? We need a crankshaft and a head and other things like that, but we'll do that in the next video.